Morning, everyone. So, first off, please excuse me if I pause to cough or anything. Unfortunately, my fall allergies have started up a little bit, but it is great to be here in The Hague again this year. Beautiful weather we've had this year. I think it's been a great conference so far. I have had a lot of great conversations with everybody. So, it's great to be here. I was when I first saw the agenda, I was a little worried if Alexi would steal some of my thunder, since we both have cloud native VNFs in our name, but I'm going a little bit lower level with what I'm going to be talking about. Just to give you a little background, very briefly, I have come really more from the device side. And manageability of devices and programmability of devices, and then later on within TLF, we grew above the device into doing service orchestration with the Network Services Orchestrator, or NSO project. So we've seen programmability from both that aspect of the device and the orchestrator. And one of the key things we've learned is how we manage things has to evolve. You know, we pioneered use of netconf, restconf, and yang technology, contributed heavily to the standards, and helped bring programmability to configuration management and monitoring of our networks. You know, we've been watching as the world of NFV has evolved, and VNFs, and now this movement towards cloud native VNFs. And it is still kind of emerging technology, early days. I'm talking to a lot of people that are looking into doing it, and everybody's really working right now on figuring out the best way to actually architect a cloud native VNF and implement it. You know, there's even debate on what should we call them. You know, is cloud native VNFs correct? Should we call them VNFs with a microservices architecture? I've even seen a couple people start using the term CNF for Cloud Native Network Function. So it's definitely a sign of early days when we see those sorts of things. So, you know, this first slide is kind of a bit of preaching to the choir, you know, of why did we go to NFV, what is the aspects of VNFs that bring benefits to operating our network. So really, it's the service velocity. In other words, how quickly can we bring up new services? You know, we all remember the days that aren't quite gone yet of, you know, a printout comes out and what we'd call a swivel chair cowboy starts typing into a bunch of different CLIs. Well, then we evolved that to, we need to automate it, do it faster. So, you know, then we script to the CLI, but now we've realized programmability is the key to automation for anything, whether we're just writing a software application or managing our networks. And that automation is what brings us that service velocity of activating faster. Agility, reacting to new demands, more load, scale in, scale out. Cost savings. You know, in the old days, everybody bought big monolithic hardware with all these cards that you'd swap in and out, failover, high availability, that all just translated to lots of OpEx and CapEx into the network. As we can move to this software-defined network and software-based network functions, you know, we get a significant cost savings along with that agility. And again, the flexibility, you know, greater freedom. You're not, you know, who runs a single vendor network anymore? Nobody. And those days have been gone for a while. It is a multi-vendor world for operating our networks. By being able to have standard APIs, standard ways of connecting and managing the software components of our software-defined network allows us to truly achieve that multi-vendor support within our network. You know, with our Network Services Orchestrator product, one of the things that really started getting us attention before TLF became part of Cisco was the fact that we used, you know, data models using Yang to describe services and devices. We used, you know, preferably programmable methods for interfacing with the elements in our network over netconf to to also being able to support CLI as needed till they got to that programmability and truly solved that multi-vendor orchestration aspect of the network. So it's really important to remember these important points for what we need in our network. But why do you hear people talking about cloud native VNFs? What are the benefits? Why can't we just stay with our VMs that we've been doing? Well, microservices is almost synonymous to containers. When people are implementing a microservice, they're using what's called a container, most typically using Docker as their platform for running their containers. There are other solutions out there, but Docker's been the most popular, with a package called Kubernetes is currently the most popular for orchestrating containers, spinning them up, spinning them down, all that life cycle management, but it gets into much more than just basic life cycle management as well. But the advantage of containers is smaller footprint than a virtual machine. When we do a VNF as a virtual machine, it's everything. It's a full operating system install. It's all these different applications and which we build the network function off of. So they're very large. So in other words, load time and memory usage. Whereas a container, you get down to you don't need that full operating system image. You put into a container, when you build it, just what is needed to run your network function applications that are within that microservice. And usually, many times a microservice is focused on a point piece of functionality. It doesn't try to be everything within one thing, but size savings, as I mentioned, memory, faster to load. So that is really some of the key points why people are looking at containers. Also, as someone who is involved with distributing and supplying software, if something is in a container, all the right versions are there. You don't have to worry about, okay, I'm going to take this software package and install it on my Ubuntu server version X.Y, and I need this package, what are all the dependencies, get these versions, spin it together. Container, as a software distributor, you can just go, here's your container, run it. Everything's there. You don't have to worry about matching anything special, and very easy. So now with these diagrams, I'm trying to illustrate the difference to help you understand a bit more difference between container-based and virtual machine-based. So in the middle here is kind of a traditional virtual machine. You've got your hypervisor, and then your virtual machine consists of the entire operating system, all your binaries, libraries, your application. And that OS is duplicated everywhere. In a container, you really have your container platform, very core minor bits of pretty much almost sometimes not much more than just a kernel for the operating system. Just the binaries, libraries with the specific versions needed and your application. So really, they look a lot the same, but if any of you are into really getting into software development, testing software, and you're running virtual machines on your laptop, and you come up with kind of a interoperability scenario or test scenario you want to try, and you're trying to run 4 full-blown virtual machines on your laptop, you can start noticing you're slowing down, your resource constraints, whereas it's much easier to spin up a whole bunch of containers because you're using less power per container in the system. But it is even possible to have something where you are running a VM and some containers, and you can start decomposing. You could have multiple instances of Docker running 2 different containers, and then effectively networking between them, and then some Docker is typically run on just one system. If I wanted to say have this whole thing in my network that's where something like Kubernetes would come into play, spinning up containers across, different actual physical instances, or call it hypervisors, and getting them connected together, connecting them to resources, etc. Now, kind of try and give you a little bit of basics, so because I realize not everybody has really studied, what is cloud native, what are microservices containers, but what I always focus on is how do we manage something effectively, robustly, easily, interoperation between vendors. So when we start looking at, once we have our VNFs as microservices, we start noticing some things. First off, increased complexity, more things to manage. Kind of generation one of VNFs was simply take my whole service provider router, virtualize it as one virtual machine, put the letter V in front of the product name, and there I have it. I have my cloud solution with virtualization. Well, that got us kind of that first step. Then people started breaking it out. I'll pull this blob of functionality, this blob, but they're all still virtual machines. So more things, each doing different things. And now with containers and microservices, the idea is decompose further, because you want to make your containers as small as possible. They're coming, they're going. They may be stateless, where you just kill it, spin up a new one with a new day zero configuration. They may be stateful, where you need to configure around. But as I list all these things, it's more and more things, which only increases the complexity of our overall network that we need to manage. It's impossible now to just manually, manage a network anymore. You need to be able to have them programmable in order to automate. And that was the one key thing I picked up that I was going to segue from Alexi's slide, is the need for API driven. We need open standard APIs. We've got a whole bunch of things. We need standard ways of managing them, but more importantly, not managing them, but think of it as programming them. APIs that we can write automation software to in order to drive this. One of the things we've been looking at a lot is how do we take a traditional device management and apply it to that microservices architecture. We've talked to a lot of people out there as we work on this issue. It's definitely still very much emerging and evolving, but one of the things we've really been seeing is looking at it as not trying to put the equivalent of a typical network device. You have your management plane, your control plane, your data plane. Not trying to put a full management plane in every single microservice and trying to manage them directly individually. The more, what we're seeing kind of more of a converge of thinking on is you'd have a management microservice. And that is where your netconf, your restconf, CLI or SNMP would go to that management microservice, and then your other microservices would be attached via APIs to your management microservices, kind of your traditional back-end instrumentation code. So that's kind of what we're seeing as the way the world seems to be going. But again, it's evolving. I'm constantly talking to people, trying to figure out how to best serve those worlds. So we've got to be flexible, we got to be agile, and we need to be programmable. I kind of want to back up to one point here where I talked about stateless and stateful microservices. There has been some move in people doing microservices where, well, I don't care about day one, day two configuration management. I'm just going to use Kubernetes to say, kill that microservice, give it a new day zero configuration, start it back up. that's good. It actually can reduce the complexity of the code and the applications within the microservice, but you still need to do something about automate changing that day zero configuration that you're telling, for example, Kubernetes to use when it starts up the container. So you need to think about, you've got your container orchestrator. You need to be able to manage the configs it's using easily for the containers that it's rolling up. But there are still more complex microservices that need to be stateful, that need to have not only their startup configuration, but be able to change their configuration as they go along. We're going to see definitely a hybrid world. We're not going to have a pure microservices-based VNF network. If we go back to like some of Dave's slides right at the very beginning where he was showing those timelines. This all evolves over time. We're always going to have hybrid ways of doing things. We're going to have a mix of physical devices, VNFs as virtual machines, VNFs as microservices. We need to manage all of that in a coherent manner, and the only key to realistically doing it is to do it via programmability. So just to kind of give a little visualization, and the product I manage is called ConfD, which is a programmable management plane solution. So I'm stealing some slides from some product stuff. So if you see ConfD, think management. So this kind of illustrates what I was talking about during the last slide of a container or microservice as a management microservice, and then my applications in other microservices or containers talking back to that management microservice. So really, to the outside world, the orchestrators, the SDN controllers, they aren't seeing individual things out there. They're seeing perhaps a unified view with one interface, so that complexity gets hidden from those upper levels. Just to kind of illustrate it also in a Kubernetes managed setup, which really, again, each of these to Kubernetes is what they'd call a node, but really it's what they call a kubelet. It's a containerized application. Kubernetes tells Docker start this, but you may be hooking to different volumes if you need some persistent storage, and these may be different, running on the same physical system. They may be on different systems. Kubernetes can kind of load balance out there, but it's really just the whole key thing here is, again, your outside world would say make your netconf connection to your management microservice, and then in your other kubelets, your applications are going back to that management service for to read their configuration data or report status. So just very quickly here, this is actually, if any of you attended my talk last year, I talked a lot about the importance of network programmability or programmability, and I just kind of wanted to really quick review. When I've been talking programmability, I'm talking APIs into my network elements, whether they're physical, virtual, microservices, VMs. It's a way to program my configuration into my network, not script it in or have somebody manually set it. I've got an API, I make effectively function calls and set data, read data, just like I'm writing regular software. It just happens to be driving my network. But an important thing for this is, of course, to be programmable, we need APIs. But we don't need just any old API. They need to be standards-based and work easily in a multi-vendor network. But we have been finding for, of course, TLF, we helped invent the technology, so of course we're fans of it, but we're also finding that it has the industry acceptance now is having a standard data modeling language to describe the management data that we're manipulating and using the Yang data modeling language as defined by IETF. Yang, I've been very happy to see, has been hugely successful in the industry. People are recognizing what it is, and they're even using it for other areas just to model data and not just network management. And then standard mechanisms for driving those APIs, preferably netconf, potentially RESTconf. The thing I really hate to see is when people say, I have programmability because I have a REST API. REST is a set of techniques, not a standard. So if you're going to use REST and present an API, don't just push the proprietary ness of a REST API that you get, kind of like all our problems with proprietary CLIs, but at least maybe use RESTconf, which is a standardized mapping. So, and I'm actually hitting the end of time here, so I'll let you, you can download slides later. I've got some examples of what the Yang data modeling language looks like with its XML equivalent. A little snippet so you can see what netconf looks like for delivering programmability. And of course, I'm a commercial vendor. I have a product. I'm focused on ConfD, which is management plane for within network elements. Come talk to me at booth B45 this afternoon, and if you want to learn more about it, or go to the Cisco booth where they can talk to you about NSO, Network Services Orchestrator, for programmability from the orchestration. And of course, I've given you some more follow-up places. Some of my talk here is based on a white paper we wrote recently that you can download, learn more about netconf and Yang. Also, we have for our ConfD product a developers conference in San Jose end of the month. And again, come see me this afternoon at booth B45 and talk to me or any of my colleagues to learn some more about this. So thank you and have a great rest of the conference.